let's take a look at our absolute value function, what it does to functions and numbers and things like that. The actual definition of absolute value is this. It's a if a is greater than or equal to 0, but it will be negative a if a is less than 0. So that is the actual definition of absolute value. And that becomes important later on. What is it? We're basically saying, well, it's the distance from 0. Distance from 0, or the origin if you're talking about a number plane. It's the magnitude, the size of the number. I really don't care whether we're going in the negative direction or the positive direction. I just want the size or the magnitude of the number. Some results then for absolute value. Some of them are very obvious, some may not be obvious. The absolute value of negative x would be the same as the absolute value of x. So remember, we say we don't really care about the negative, it's the size of the number we're interested in. Therefore, the absolute value of x minus y must be the same as the absolute value of y minus x. They would give us the same size, just one would be negative, one would be positive. Multiplying together. Well, I guess this one's saying it doesn't really matter whether you multiply the numbers first, then find the absolute value, or find the absolute values first, then multiply them. Same with division. The absolute value of x squared will be the same as x squared. However, and we have talked about this one, the square root of x squared will be the absolute value of x, not just x. Okay, let's look at that. So absolute value negative 5, what we're saying is, well, I don't care about the plus or the minus, I just want the magnitude, the size of the number. That's 5. Absolute value signs, they are grouping symbols. So all our rules for mathematics are the same. And we always do what's inside the grouping symbols first. So 6 minus 8 minus 2 is negative 4. What's the size of that number? It's 4. Order of operations. We do what's inside the grouping symbol first. 6 times 3 is negative 20. So we're saying 7 minus the absolute value of negative 2. So the size of negative 2 is 2. We get 5. It is a grouping symbol. So just like in algebra, with grouping symbols, we don't usually write the multiplication sign down. I mean, it's not wrong to write it down, but we often just say it like this. So this is saying 3 times the size of negative 6, 3 sixes are 18. Now this question, the square root of x squared if x is less than 0, well, the answer is negative x. Because we're saying the positive square root, I know the answer has to be a positive number, but they're telling me x is a negative number, therefore the answer should be negative x. What does the graph look like then? Here's a linear function, y equals mx plus b, but we're finding the absolute value of mx plus b. What basically happens is whatever is below the x-axis gets reflected above the x-axis, because the answer is always positive. So all those negative numbers turn into positive numbers. It reflects above. The most basic of them all, y equals x, so we end up with the V shape. The bit below has been reflected above. If I was asked to draw this graph, I probably wouldn't just put the V in. It has no sense of scale there. So we usually whack a couple of points on to give it some sense of scale. I've got 1, 1 and minus 1, minus 1. So I had to sketch y equals the absolute value of x plus 2 then. There's a couple of different ways I could think about this. I could say, well, the basic curve is y equals the absolute value of x. There it is there. But what have I done? Now, they're grouping symbols, so I've grouped it with the x. So I've shifted it left 2 units. Shifted left 2 units, there it is. Whack a couple of points on it, give it some scale, and we have our absolute value of x plus 2. That's one way of thinking about it. Another way I could think about it is, well, no. I'm starting with the line y equals x plus 2. But whatever is below gets reflected above. I end up with the same picture. And there's a couple of points. What about y equals the absolute value of x plus 2? Well, now I've got my basic curve, but I'm shifting the whole thing up 2 units. So up we go. There it is. Solving equations then. Now I start off with a very simple one to illustrate a point. Sure, you might just look at that and go, well, x is either plus or minus 7. Think about it differently. Think back to the definition. Yes, it's x equals 7 or x equals negative 7, but why is it? Well, maybe it becomes more obvious when we now look at ones like this. Absolute value of 2x minus 3 is equal to 7. Go back to the definition. Because what I'm saying is, well, either 2x minus 3 is 7, or the negative 2x minus 3 is equal to 7. So remember, it branched into two things. It was either a or negative a. Then I solve each of those independently. On the left I get x equals 5, on the right I get x equals negative 2. And it gives me my two possible answers for this equation. You break it into its two branches, if you like, of the graph. Because when you've reflected that above, you've actually ended up with two branches. One is the line, well, in our case, one would be the line y equals 2x minus 3. The other branch would be the line y equals 3 minus 2x. We say, when does that intersect with the line y equals 7? Well, it's in two spots, and that's what we've just found. So again, something like this, I would go, well, either 2x plus 6 is 3x minus 1, or the negative of 2x plus 6 is 3x minus 1. Solve each of them independently. Now, a lot of people would just be happy to write down the answer, x equals 7 and x equals negative 1, but, of course, x equals negative 1 is not a solution. So if you go and substitute it back in, the right-hand side becomes negative 4, and it's impossible for an absolute value to equal negative 4. When you do things like this, sometimes you will create new solutions that aren't actually solutions, because you have transformed this equation into something else to make it easier for you to find the answers. But when you transform it, maybe you've created new solutions. You always check and make sure that is it an answer to the original question, not the new questions that I've created, but the original ones. And in fact, if you've got absolute value equals, and then on the right hand side something with pronumerals, if it's just a number, it's not going to be an issue, then that's when you may well produce an answer that's not a solution, because you're going to be substituting into that pronumeral. If it's like example 2 there, well, it doesn't matter because I've got a constant 7 on the right hand side. I know it's not going to be an issue. So that's the one we want to look out for. 40.